going to be going through the Quiz 4 study guide, which is on Unit 2 Learning Target 1, which is about arithmetic and geometric sequences. So this first section is just determining if the sequence is arithmetic or geometric, and then if so, figuring out its common difference or common ratio. Now, this is not a 10-minute problem, right? If this were to be on the quiz, there would be multiple of them in 10 minutes, but to be honest, it's probably not going to be. Practicing these types of problems are more to get us more familiar and comfortable with arithmetic and geometric sequences so that we can do those harder problems, right? You need to know how to do the easy stuff and be comfortable with the easy stuff to do the hard stuff. So looking at these, when I'm trying to determine if something is arithmetic or geometric, I eyeball it first and then check. So this one, for example, right, 2.6, 3.4, 4.2, 5, 5.8, it doesn't look like the gap between these is too different, right? It doesn't look like the gap between this is much different than the gap here or much different than the gap here, right? It kind of looks like it's constant. That doesn't mean it is, but that means that I'm going to start by assuming this is arithmetic and checking. So we know for arithmetic sequences, they have common differences, and that's going to be A2 minus A1, right? So I'll do 3.4 minus 2.6, and I'll get that my potential, so I'll put it in quotes, my potential common difference would be 0.8. If one existed, it would be 0.8. So I have two options. I can continue to subtract my terms. I can do I can do 4.2 minus 3.4. I can do 5 minus 4.2 and verify that all of those are 8, right? Because I know that all of these have to be equal. Or I can just simply get in my calculator, do 2.6 plus 0.8, see that that's 3.4. 3.4 plus 0.8, I'll see that that's 4.2. 4.2 plus 0.8 is 5. And then 5 plus 0.8 is 5.8. So we can see it does check out. The common difference is constant, which means that this is arithmetic and has a common difference of 0.8. It's arithmetic and its common difference is 0.8. Okay. I could have checked to see if it was geometric by looking for a common ratio, but I kind of like common sense look at it and see which one it's more likely to be to narrow down the chances that I waste my time checking for something that's not true. So what I mean by that is if I look at this second one, to me, what I mean by that is if I take a look at this second one, to me, it's clear that the gap is very different, right? That the gap between these two terms is smaller than the gap here, right? To go from 4 to 22, then from 600 to 3,600, they're clearly very different. So that tells me, okay, there's no way this is arithmetic because the gap, the difference is not common, and it's obvious that it's not common. So I will first check to see if it's geometric by finding what the common ratio could be and verifying that it stays that way. So again, my could be common ratio would be A2 divided by A1. So 22 divided by 4, that's going to be 5.5. Okay, again, I can check it. I know it goes 422. 22 times 5.5 is 121. 121 times 5.5 is 665.5. I do it again. And yes, indeed, this checks out. Okay, so that wasn't just like random, oh, I'm going to try this one as geometric first. Looking at this, I can see the gaps are clearly not constant, which means it's not arithmetic. And then I check to see if it is geometric, and yes, indeed it is. It's geometric with a common ratio of 5.5. So for these next problems, I'm asking for the explicit formula. Remember, the explicit formula is the formula that allows us to find any term of a specific sequence. For arithmetic sequences, we know our formula for all arithmetic sequences that exist is this, but for it to be an explicit formula specific to a sequence, we have to plug in A1 and we have to plug in D. We know for a geometric sequence, our formula for any geometric sequence is this, but again, to write a formula that is specific to a specific sequence, we need to fill in A1 and R. So for these problems, even though the instructions don't say figure out if it's arithmetic or geometric, then figure out the common difference, common ratio, that's actually the exact same steps we need to take here. There's just one more step of plugging them into the formula, right? A lot of these questions, you kind of have to fill in the steps, fill in the gaps to be able to figure out what it's asking for and what you need to put as your answer. So here it's looking for a formula with A1 and D or A1 and R filled in. I have to figure out what formula I'm using first. So if I look at this, 100, 50, 25, 12.5, 6.25, again, it is clear to me that the gap between 50 and 100 is bigger than the gap between 6 and 6. And so when the gap is changing, it cannot be arithmetic. So we're going to check and see if it is geometric. Because I have a feeling that this is geometric, I'm going to find the potential common ratio first. So we know that our common ratio is always A2 divided by A1. A2 is 50, A1 is 100. That simplifies to a half. Once I have my potential common ratio, I can just do a real quick check in my calculator to see if it's true, right? 100 times a half is 50, 50 times a half is 25, 25 times a half is 12.5, and 12.5 times a half is 6.25. So it does check out, and this is geometric, which means that I am using this formula for this problem. Okay, my explicit formula is just inputting A1 and R. Well, I've solved for R, and A1 is given to me in the problem, right? A1 just stands for first term. So I can finish this problem out, and I know that AN equals A1 times 1/2 to the n minus 1. And now this equation would allow me to find any term in this sequence I wanted. I want you guys to keep in mind that the common ratio is always being multiplied. Yes, you can get from 100 to 50 by dividing by 2. You can get from 50 to 25 by dividing by 2, but you can't plug in dividing by 2 into a formula, right? The common ratio is always what you're multiplying by. If you're dividing, you're multiplying by a fraction. So just keep that in mind. All right. For number 4, I'm not super certain right off the bat which one this is, arithmetic or geometric, because decimals are involved. But after a little more inspection, I can see that the jump does look fairly constant, right? You know, we're not going up by crazy amounts in between. So my assumption would be that this is arithmetic, right? You guys are going to have one arithmetic question and one geometric question on the quiz. So if your first one's geometric, you automatically know your second one's arithmetic. Okay, so looking here, my common difference is always going to be A2 minus A1. That'll be negative 1.2 minus a negative 0.8. That's going to be negative 1.2 plus 0.8, which is negative 0.4. Okay, we'll do a quick check to double check, make sure that that is indeed the case. So, start with negative 0.8 in your calculator, subtract 4, checks out, subtract 0.4 again, checks out, subtract 0.4 again, yes, subtract 0.4 again. We can see that it is arithmetic. It does have a common difference, and that common difference is 0.4. That means that this time we're using this formula, okay? This time we are using this formula, and again, it's just a matter of plugging in. So AN equals A1 is going to be negative 0.8. D is negative 0.4 plus a negative is the same as subtraction times n minus 1. And now this formula would allow us to find any term of this sequence we wanted. So for these next questions, we are again needing to determine if it's arithmetic or geometric first, then we're finding a term. The reason we have to figure out if it's arithmetic or geometric is so we know which formula we are going to use to solve this. So I'm looking at this 75, 70, 65, 60, 55, right? That, to me, I recognize the pattern instantly. But even if I didn't recognize the pattern instantly, at the very least, I can kind of tell that it looks like a constant rate, right? The gap between 75 and 70 and 60 and 65 or 60 and 55 is not that different. It's not, I don't know exactly what it is technically because I haven't calculated it yet, but my assumption would be first that this is arithmetic. So to check if it's arithmetic, I start by saying, okay, I think this is arithmetic, so I'm going to say that I have a common difference of A2 minus A1. That's going to be 70 minus 75, right? The order is very important, and that's going to be negative 5. It means I'm adding a negative 5 every time, which is the same as subtraction, right? So to check to see if that's true, I just pull up my calculator and I do, okay, 75 minus 5. Yep, that's 70. 70 minus 5. Yep, that's 65. 65 minus 5. Yep, that's 60. 60 minus 5. Yep, that's 55, right? None of this stuff I have to actually write out, on my quiz, but that is how I confirm that this is indeed a arithmetic sequence. Now that I know it's arithmetic, I know I'm working with this formula. AN equals A1 plus D times n minus 1. Keeping in mind that AN is the value of the nth term, A1 is the first term, D is the common difference, and n is the position of the term in the sequence. Okay? I can pull both of those things now, right? I can see A1 in my sequence. I can see the common difference. We just solved for it. So now I have my formula. My formula is going to be AN equals 75 minus 5 times n minus 1, right? That is my explicit formula. I need this explicit formula to be able to find my 11th term, right? So when I ask for the explicit formula on the quiz, I'm looking for the formula with A1 and D in it for arithmetic. To find A11, that tells us that n equals 11. So what I do there is go ahead and plug in 11 wherever I see an n. In my problem, that's going to be 75 minus 5 times 10, right? 75 minus 50. And our 11th term, our final answer here, is that A11 is 25. And this one's done. All right, for this one, and here's kind of what I meant by for the last one, we could see that it was constant. For this one, it's pretty clear to me that the difference between, 1/3 and 3 is not the same as the difference between 27 and 200, right? I'm not actually calculating what that difference is, but I just know that they're going to be different. So I know for sure it's not arithmetic, so I'm going to start by checking to see if it's geometric. right? So we know for geometric sequences, the common ratio when we're given, a list of sequences is either A2 over A1, and it also has to be A3 over A2, and it has to be A4 over A3, and so on. All of those have to be equal for it to be common. But we'll just check and see, okay, we'll do 1/3 over 1 over 27. That's if you're not a fan of fractions, you can do, you can check and see 243 over 27, right? Because again, theoretically, if it is geometric, all of those would need to be equal. But you can just type it into your calculator. We also know that when we divide fractions, we keep change flip, right? So really, this is the same as 1/3 times 27 over 1. Which does simplify to 9, right? This also would simplify to 9. So our potential common ratio is going to be 9. And now we just need to check it. Again, this time I'm just going to do it in my calculator. I'll do 1 divided by 27 times 9. 1/3 times 9 is 3. 3 times 9 is 27. 27 times 9 is 243. So I can see that it does check out. It is a geometric sequence, which tells us that we are using this formula to find the terms, right? This is the geometric sequence formula. So I have my A1, again, I can just see it in my problem. I have my R, I solved for it. So my explicit formula is going to be AN equals 1 over 27 times 9 to the n minus 1. If I want to find the 8th term, A8 is telling us we're looking for the term in position 8. So I will plug in 8 for n. So A8 equals 1 over 27 times 9 to the 8 minus 1, 1 over 27 times 9 to the 7th, and then this is just going to go right into my calculator, parenthesis 1 divided by 27, close parenthesis, times 9 to the 7th, and I will get 177,147 as my final answer to this problem. Now we're getting into the questions that require a little more maneuvering. It's not as straightforward, here's the formula, input, find this term. We have to use what we have to answer the questions being asked. So this says, given A71 is 52 and A75 is 12, find the common difference of the arithmetic sequence and A15. Okay, so we have to use the points that we have to find that common difference first. Then it doesn't say it in there, but we have to find A1 to be able to find A15. Then we can finally find our 15th term, right, using that explicit formula. To do this, we're going to find the common difference first. Now, we've done a couple of these in class, and we've kind of always thought it through as, all right, here's some terms, whatever. Here's my 71st term is 52. Then I have my 72nd, 73rd, 74th, and my 75th term is going to be 12, right? So I just it was ugly too. So what I have to do is see, okay, if I did have my common difference, I would fill this in by, add the common difference once, add it twice, add it 3 times, and add it 4 times to get from 71 to 75. But not all of the problems we are going to do is going to be close enough to draw out. So really, this number comes from doing 75 minus 71, right? The 75th term position minus the 71st position would be 4 jumps that we are making, okay? We're adding the common difference 4 times, but in total, that's going to total to whatever this jump is, right? How did I get from 52 to 12? It's a total difference of negative 40, right? The total difference is negative 40, but I need to break that down into 4 equal jumps, right? My total difference is negative 40, but that needs to be broken down into 4 equal jumps. We divide things up using division, so I'll get that my common difference is negative 10. Okay, this is the logic our way through it way to kind of do this. And it's a little easier to see when they're closer together like this, but the formula The formula we can use for all of these, no matter how far away they are, how close together they are, is that the common difference is going to be whatever the output of your second term is. So this is going to be an2 minus the value of your first term, an1, divided by the actual term number. So we can see that 75 is n2, since that's a75. Minus this is going to be n1, it's your first term, and then we can plug it in. So the idea comes from, the fact that we're jumping this amount this many times, but if you are more of a formula person, the way that you do it for all of these is going to look like this. Notice the order is very important. If you do it in the wrong order, you will get the wrong sign on your difference. And notice, these go together, these go together, right? They have to be paired up like that, okay? Just evaluate it out. You get, again, negative 40 over 4. That's going to be negative 10. So now we have our common difference. So, that's great. We've got our common difference, and we are able to then find A1. Right? I know that I have to still find A1 because, okay, cool, I've got my common difference. I'm using this formula because it says that it's arithmetic, right? It tells us that it's arithmetic. So I'm using this formula. I now have my common difference, which is great. I can plug that in. But if I was to try and find A15 right now, I can't find it because I still don't have A1, right? I have a missing value. I can't calculate A15 until I have that A1. What am I going to do to find that A1? I need to use one of the points I'm given. It doesn't matter which one because both of those are input and output pairs, right? Because right now I'm looking at AN equals equals A1 minus 10 times n minus 1. Knowing that A75 is 12 tells me that when n equals 75, when I'm looking in the 75th position, my output is 12. My term is 12. So I can plug in 12 for AN, and I can plug in 75 for n, and then I have an equation that I can solve, right? I'll put 12, because that's what A75 is, equals A1 minus 10 times 75 minus 1. Okay, then that's going to be 12 equals A1 minus 10 times 74. Okay, 10 times 74 is 740, so now I have 12 equals A1 minus 740. I'll add 740 to both sides. I will get that A1 is 12, and that, no, I'll add 740 to both sides. I'll add 12 to 740, and then I'll get that A1 is 752. So now I can plug that in here and I can actually calculate my 15th term. So now, again, I have my A1. I have my explicit formula is AN equals 752 minus 10 times n minus 1, and I can just find the 15th term by inputting 15 for n. So A15 equals 752 minus 10 times 15 minus 1, 752 minus 10 times 14, and then this can just go straight into my calculator, 752 minus 10 times 14. Our 15th term is going to be 612, and this problem is done. Okay, this problem is too long to do in 10 minutes. This problem is too long for 10 minutes. The first part of this problem, just finding the explicit formula, not bad. That's doable in 10 minutes, right? Finding the common difference, finding A1, but then adding on top of it, finding the 15th term, it's a little much for a 10-minute quiz. This problem, it says we're given A2 equals -4, so that means the second term is -4, and R is -2, and we're being asked to find A19. Now, looking at this, I don't have a sequence to determine if it's arithmetic or geometric. I'm not told if it's arithmetic or geometric, but this piece of information right here tells me that this is a geometric sequence, right? Only geometric sequences have common ratios. So we are going to be using this formula to solve this problem. Okay, and I can see, okay, let me plug R in because that's already given to me, right? If I'm not sure what to do next, I take a look at what it's asking me to do. It's asking me to find the 19th term. So to find the 19th term, I would plug into my formula 19 for n. Now it can clearly be seen that to find the 19th term, I'm going to need A1. So I need to go back to the information I'm given and figure out if I can get A1 from that. And I actually have two options here to find A1, right? I'm given A2, right? So if this is a sequence, if I have my sequence, it's going to go, okay, A1, A2, A3, so on. Well, I know A2 is -4. I know to find A3, I would multiply by -2. The opposite of multiplication is division. So to go the other way, I would divide by -2. So one way I can figure out what A1 is just by looking at it like that, because I have A2. It's not like the only thing I have is what A70 is. Since I have A2, it's quick to go back. But say, let's just do the formula way, just in case we would see one where we don't have A2. We have something like A15 or A80 or just something where there's no option to go back like this. The formula we would set up, we know that our output is -4 when our input is 2. So we would just solve this for A1. -4 equals A1 times -2 to the first. Then it would be -4 equals -2 times A1. Divide both sides by -2, and you would get A1 equals 2. So honestly, the same process, but that's just because we're working with A2. That's what we have. So what we do now that we have A2 and R, we've got ourselves the explicit formula. I can plug in A2 here, or A1, my apologies, and now I can calculate my 19th term. 2 times -2 to the 18th. Make sure you use parentheses when you type this into your calculator, -2 close parentheses to the 18th. When you raise a negative to an even power, it should be positive. But if you don't put the parentheses there, it's going to give you a negative. So I'll get 2 times 262,144. And then A19 is going to be 524,288. And we are done with this problem. Okay. So even though it didn't explicitly ask us to find the first term, we needed to find the first term to be able to find the 19th term because we had to plug it into our formula. So looking at number 10, we have find the number of terms in the arithmetic sequence 4, 7, 10, ... 376. So you may want to just say, hey, there's 4 terms, but that ... there's a bunch of terms between all these terms. We are not going to sit there and list them out. We are going to use what we know about arithmetic sequences to calculate the number of terms, right? First thing we notice is that I did tell you it was an arithmetic sequence. I didn't actually need to do that. Just trying to be nice. But you have enough terms to determine that it's arithmetic, but regardless, we know it's arithmetic, so we know we're using this formula, right? We can see from the sequence that the first term, my apologies, is 4. Then the common difference, we know the common difference is A2 minus A1 or A3 minus A2, so that's going to be 7 minus 4, which makes the common difference 3. So I can also put that into my formula. So now I have my formula that I'm going to use. I'm looking for the number of terms in this sequence. The number of terms in this sequence is going to be determined by the position of the term 376, right? If 376 is the 80th term, then there's 80 terms total, right? If I have a list of things, right, here's my list, and the last thing on the list, whatever it may be, is the 10th thing on the list, that means that there were 9 more before it and I have 10 items total, right? The position of the last thing is also the number of things that we have. So if I can find what term 376 is, then I know the total number of terms since it is the last term. So I'm actually looking for n. I'm looking for n because I'm looking for the position of 376, which would make the nth term, an, 376. So I just plug that in here, and then I have one variable I'm solving for. So 376 equals 4 plus 3 times n minus 1. I will subtract 4 from both sides. That is going to give me 372 equals 3 times n minus 1. Then I will divide both sides by 3. Right, divide both sides by 3. So that cancels here, and we will get 124 equals n minus 1. Simply add 1 to both sides, and you will get that n is 125. And what this means that the 125th term is 376, but since it is also the last term, that means that there is 125 terms in this sequence. This problem says, given A1 is 2 and A5 is 162, find the common ratio for the geometric sequence and A11. So looking at this one, I'm told it's geometric. I have to be told that. I don't have enough information to determine that on my own. So that means that we are using this formula. Okay, before I even think about what I'm trying to solve for and what I need to solve for, I'm just going to input the information I have, right, for this formula, and that's that A1 is 2. So far my formula is 2 times r to the n minus 1. And it's asking me to both find the common ratio and A11. Had I just been asked to find A11, I would still need to find the common ratio first because I can't find A11, right? Finding A11 would be A11 equals 2 times r to the 11 minus 1. I can't do that until I have r. So the first thing I'm going to do is find r, and I'm going to use the fact that I know that a to the A5 is 162, because that tells me, okay, when n is 5, when n equals 5, my an is A5, but I know what A5 is. So I can plug both of those in, and all of a sudden I have myself a equation with one unknown, right? 165. I don't know where 65 came from. That's 62. 162 equals 2 times r to the 5 minus 1. 162 equals 2r to the 4th. Divide both sides by 2. 162 divided by 2 is 81. 81 equals r to the 4th. Take the 4th root of both sides to undo the power of 4, right? We undo the power of 4 with the 4th root. But the way that you type that into your calculator is going to be 81 to the 1/4 equals r, right? You'll type in 81 in parentheses raised to the 1 divided by 4 in parentheses, okay? That is how you take a 4th root in your calculator, and we get that r equals 3 when we do that. Okay, so now I have my explicit formula. Now I have my explicit formula is, let me just add it in here. I'll just put it back in here. Is going to be 2 times 3 to the n minus 1. Okay, if instead of asking for just the common ratio, I asked for the geometric explicit formula, this is what you would need to give me. You would still have to find the common ratio, but you would need to put it in this form. Okay, now finding A11 is actually possible because I have my r, and now it just becomes a calculator problem, right? I just type into my calculator 2 times 3 to the 10th That is a very large number. I write it down on my paper, and I am done with this problem. And the study guide, right? Okay, so that was my walkthrough of the study guide. You can find this PDF answer key on Schoology. Let me know if you have any questions about anything I did in here. The other homework assignments are also a great study tool. Good luck. So long as you prepare, I promise you, you are ready.